This is problem number 3.1 in the NCERT book for class 12 part 1. The first problem, and it's a very simple problem, but I wanted to go through its theory behind it. We have a car battery, a storage battery of a car that has an EMF of 10 volt, 10 to 12 volt. It's a 12 volt battery, a regular battery that we use in our car and everything, and has an internal, every battery has an internal resistance, and that is actually not a very useful thing, because when the current flows through this resistor, it heats up, number one, and it's a wastage of the car energy that could be used on somewhere else. The question is, what is the maximum current that can be drawn from this battery? Now, this resistor limits the maximum current that can be drawn from this battery. And we will understand, we need to calculate what is that maximum current that we can draw from this battery. We'll understand it with a little example. Let us say from this car battery, we have connected some external thing, the bulbs, the chargers, everything else that we can think of that runs on this car voltage. So let's say call this resistor Rx, okay, and the current through this battery now is given by the simple voltage law, Kirchhoff voltage law, I equal to V by R. Or now the resistance is the sum of this resistance, internal resistance of the battery, and the external resistance Rx. So we have Rx plus 0.4 ohm. Let us say that we have connected some bulb or whatever that has a resistance of 2 ohm. In that case, the current will be I equal to 12 divided by 2.4. 2 plus 0.4 is 2.4. This is 0.2. So 1 divided by 0.2 is 5 ampere. So if we connect a 2 ohm resistor, then the current is 5 ampere. What if we reduce this resistor to, let's say, 0.8 ohm? In that case, the current will be I equal to 12 divided by 0.8 plus 0.4, which is 1.2 and 10 ampere. As we reduce this resistance, the current increases. If we further reduce it to 0.2 ohm, then the current will be I equal to 12 divided by let's say 0.4 ohm actually. Then the current will be I equal to 0.2 ohm. 0.2 ohm, 0.4 ohm is the internal resistor. So I equal to 12 divided by 0.2 external resistor and 0.4 internal battery resistance. 12 divided by 0.6 is 20 ampere. Now if we go on this way, we notice that the current keeps increasing 5 ampere to 10 ampere to 20 ampere as we reduce this resistor. Now, what if we just short this? We just join these wires. Sometimes it happens accidentally, and in which case it creates a spark. We need to find out what that maximum current is going to be. So in this case, that current will be, if R is equal to 0, this current is going to be I equal to 12 divided by 0.4 or 30 ampere. So we can expect, if we want to draw more than 30 ampere of current through this battery, then it's not possible. It is limited by the internal resistance of this battery. It was a very simple problem, but I deliberated on doing extra thing just to make sure we understand this concept. Thanks for taking a look.